Can all of you see my screen? Okay, thank you. Thank you to those that responded. Okay, so what am I planning to cover today? I'm going to first discuss the principle of superposition. Then we'll start a discussion of equivalence when a circuit contains sources. In particular, we're going to discuss source transformation. So first, let's discuss the principle of superposition. Okay, the principle of superposition reads as follows. In a linear electric circuit containing n independent sources, the current or voltage in any part of the circuit can be expressed as the algebraic sum of n components, each of which is due to each independent source acting alone. Okay. Now, mentioned this way, it might be difficult for you to comprehend. Let me just put it this way. Sabihin natin meron akong circuit with, let's say, 3 sources. It can be a voltage source, can be a current source. 3 independent sources. It has to be an independent sources, no? Can be a voltage source, can be a current source. Any voltage or current in this circuit can be expressed as the sum of 3 components. Each component being that particular voltage or current due to that particular source acting alone. So you have 3 sources. You consider each source acting alone. That source acting alone will contribute a certain voltage or current to a part of a circuit. And if you get the sum of all of these components with all of the sources acting alone, that will be the total response of the circuit. Okay, a source is considered acting alone if all the other sources are suppressed. To suppress a source, if it is a voltage source, you replace it with a short circuit. If it is a current source, you replace it with an open circuit. That's how you suppress a source. Other times we say reducing the source to 0. Ulit, no? Voltage source replaced with a short, current source replaced with an open circuit. Let's jump into an example. Use the principle of superposition to determine I1 and I2 in terms of the circuit parameters. So let's assume we know Vs, we know Is, we know R1, and we know R2. I want to get an expression for I1 and I2. And I'm going to use the principle of superposition. Okay, so let's do this. No? So first, let's consider V of S acting alone. Oops. Sorry, I don't like that color. So consider V of S acting alone. What is going to be my equivalent circuit? I'll have V of S. Okay, I have R1. I have R2. What will happen to my current source? Anyone? What will happen to my current source? Sigaw na lang ninyo, no? What will happen to my current source?
Will be
Ano yan? Renz?
it is as if poster inalis po talaga yung part ng current source.
Okay, tinanggal natin, no? In effect, it will now be an open circuit, no? So the current source is replaced by an open circuit. Okay, what are my currents? My currents are this. This is my original I1 and this is my original I2. Okay, with Vs acting alone, let me call this I1A. I1A. And then let me call this I2A. No? So I2A is I2 with VS acting alone. I1A is I1 with VS acting alone. Ano magiging value ng I1A at saka I2A? Anyone? What is the value of I1A and I2A? Yes, sige, Renz, ulit.
VS over R1 plus R2.
Okay, that's right. Ano? Kasi because this is now an open circuit, I now just have a single loop here. Single loop here. In other words, yung current na ito at saka yung current na ito pababa should be the same. No? So I1A will be equal to I2A will just be equal to VS over R1 plus R2. So that's half of my problem solved. So now what do I have to do? Now I have to consider IS acting alone. So consider IS acting alone. Okay, so ito yung IS ko. Okay. I have R2. I have R1, R2. Ano nga yung mangyayari dito sa VS ko? Can I hear somebody else? What will now happen to VS? Anyone? Yes? Siri?
It will be replaced with a short.
Yes, that's right. Ano? So we want to suppress VS, so we replace it with a short. No? So VS replaced by a short. Okay. So I have to follow the reference directions of I1 and I2 here. No? That's very important. Kung ano man yung reference direction ng I1 and I2 established dun sa problem, kailangan sundan ko yun. No? So this is going to be my I1B now. And this will be my I2B. No? I1B being due to IS acting alone, I2B being I2 due to IS acting alone. Okay, umpisahan natin sa I2B. Can somebody give me an expression for I2B? First of all, what can we use? No? What technique can we use to solve for I2B? Anyone? Can I call people at random if nobody will volunteer? Yes, Romeo.
Current divider, sir.
Yeah, current divider, no? So, tuloy mo, no? So what will be I2B?
Bali, sir, IS
IS,
multiplied by
sorry about that. Okay, it's IS
multiplied to the quantity of R1,
IS multiplied by, sige, R1,
quantity R1 over R1 plus R2.
R1 plus R2. Okay, that's correct, no? Okay, that's I2B. What about I1B? Iba naman, I1B. Who can tell me what is I1B? Anyone? Anyone? Trying to wake you guys up. Sige, Siri again. What is I1B?
It will be IS times R2
Okay.
all over R1 plus R2.
How many disagree? How many agree? Can I say a show of hands? Kahit show of hands lang, no? How many agree? Unfortunately, there's a slight mistake. What is that? Balik tayo kay Siri. Do you see?
Should it be negative?
Yeah, it should be negative, no? Because if you follow the current division principle, No? If this is the current flowing into this node, then it should flow down to R2 and flow right to left to R1. But since our reference direction is left to right, then this should be now negative. No? Again, you have to be very careful of things like that. Okay, so I know the contribution to I1 of VS. I know the contribution to, okay, I know the contribution of I1 and I2 of VS. I know the contribution of I1 and I2 of IS. Then finally, no, my I1 will just be equal to I1A plus I1B, which is going to be VS over R1 plus R2, okay, plus minus IS in this case, R2 over R1 plus R2. No? That's I1. And I2 will now be I2A plus I2B, which is VS over R1 plus R2 plus IS multiplied by R1 over R1 plus R2. Any questions? So it looks quite straightforward. So let's take up another example. Okay. Determine the current that will flow through the 3 ohm resistor, itong 3 ohm resistor. Okay. If the switch is in position A. If the switch is transferred to position B, what current will now flow through the 3 ohm resistor? So let me call the current flowing through my 3 ohm resistor. Let me call this I sub X. Okay, here's my first question. If the switch is in position A, will the 6 ampere source contribute to current flowing in the 3 ohm resistor? Yes or no? Okay. I just want to get a consensus, no? Yes or no? Again, no? If the switch is in position A, okay, will my 6 ampere source be contributing current flowing through the 3 ohm resistor? Yeah, just give me a check or an X. Are you sure you're not just copying from each other? Okay, so some say yes, some, well, most say no, some other people say yes, no? Okay, I guess the majority is correct, no? No, no? Why is that so? Okay. Kung yung switch natin nasa position A, itong 6 amperes of current will just be circulating in this particular loop. None of this current will flow here. Why? Because if it flows there, it does not have a path to go back up. In other words, this particular part of the circuit is like a floating circuit. Okay? So when the switch is in position A, itong 6 amperes, walang effect dito sa I sub X. So in position A, it is only these 2 sources that contribute to I sub X. Now, I'm not going to use superposition in letter A. No? This is also going to give you a chance to review nodal analysis. Okay, so with the switch in position A, let's compute for I sub X. So with switch in position A, that means the 81-volt source and the 9 ampere source will be working together. So let's compute for the contribution of the 81-volt source and 9-volt source and 9 ampere source to I sub X working together. Okay, anong pwedeng gamitin kong technique, no? Sige, gamitin natin ang nodal analysis. Let's just use nodal analysis. Okay. What is my equivalent circuit? Tatanggalin ko lang to, no? I'll just take this out. So my equivalent circuit we look as follows. I have my 81-volt source. Okay, then I have the 6 ohms here and 6 ohms there. Then the 9 amperes, 12 ohms, and 3 ohms. 9 amperes here. Okay. I have my 12 ohms. And then I have my 3 ohms. And I want to compute for, let me call it IXA. IXA being the current flowing through the 3 ohm resistor with these two working together. So, nodal analysis, so sabihin natin ito yung gagawin kong reference. Gawin ko yung reference node. Okay. Let me call this node X. No? Node X. So essentially what I want to compute for is V sub X. Okay. So can I ask for a volunteer that will tell me what is my KCL at X? Volunteer, please. If I don't get volunteers, I'll just call people out randomly. No? So, any volunteer? Sige. Can I ask Will Benjamin, what is KCL at X? Can you unmute yourself and tell me what KCL at X is?
KCL at X.
Yes.
Six. Wait. I'm not so sure.
Okay. Sige, one by one, ano? What is the current flowing through the 12 ohm resistor from left to right?
Vx over 12 ohms.
May kulang, no?
Yeah.
It's Vx over 12. It's Vx minus this voltage over 12, ano? Because when
Yeah.
you say Vx over 12, then you must make sure that Vx is the voltage across the 12 ohm, no? But Vx is not the voltage across the 12 ohm. The voltage across 12 ohm is Vx minus the voltage at this point, no? You can get an expression for the current here from left to right. What is it going to be? It's going to be Vx over just 12 plus 3. No? Okay. Vx over 12 plus 3. Okay. Now, what about the contribution of this?
-9.
Okay, -9. Good, no? What about here from right to left? That one's a little...
Yeah, wait.
Okay. It's going to be Vx.
Vx over 6 ohms.
Again, be careful, no?
Yeah.
When you say Vx over 6, that means you're assuming that the voltage across the 6 ohms is Vx.
No, wait.
But it's not, no?
Is that 81 volt?
Yeah, that's 81 volts. Okay, what you pretend to do is, itong 6 ohms na to, this 6 ohms, try transferring it up there, no? Remember what I said, that when you have elements in series, you can rearrange the elements in series and it won't affect the current flowing through that particular branch, no? So if I try transferring this up here,
Isn't
So
that parallel though?
okay, so what's the expression going to be? It's going to be Vx. Anyway, it's going to be Vx minus 81 over 6 plus 6 or 12. No?
Okay.
Okay. Anyway, that should be equal to 0. Okay. That's KCL at X. It's okay, Will, no? You just have to practice. Okay. Any questions with regard to this equation? So the first term is the current flowing to the right here at the 12 ohm. The second term is the current flowing into X because of the 9 ohm source. The third term is the current flowing from right to left here at the 6 ohm. Any questions? Okay, if I solve for Vx, so there's only one unknown here. If I solve for Vx, I'm going to get Vx is equal to 105 volts. So that's just now a simple math problem. So now what is IXA? Can somebody tell me what IXA is? Yes, Alberto.
8.75 amperes, sir.
Just tell me the formula, no? The formula.
It's 105 over 15 ohms, sir.
Yeah, Vx over 15, no? Basically.
Yes, sir.
Okay, that should be 7 amperes. That should be 7 amperes, not 8.75. You made a mistake somewhere in your calculator, no? Okay. So anyway, that's Anyway, thank you, no. So that's IXA. Okay. So that solves for letter A, no? That's the current that will flow through the 3 ohm resistor with the switch in position A. Now let's say we transfer the switch to position B. So the switch now we transfer to position B. Now here's the thing. I already know the contribution of these two sources to my IX. So all I have to do now is determine the contribution of this source to my IX. To do that, I suppress these two sources. Okay. So what is my equivalent circuit going to be? So to suppress the 81 volt source, what is it going to be? No. So this is now with all three no. What I'm trying to get now is the 6 ampere source acting alone. Okay, so what I do is I suppress the 81 volt source and I suppress the 9 ampere source. And I assume that the switch is now in position B. So what is my equivalent circuit going to look like? My 81 volt source is going to be a short circuit. Okay. Then I have my 6 ohms here. My 9 ampere source is going to be an open circuit. Okay, sorry, I have another 6 ohms here. Okay, then I have my 12 ohms. Then I have my 3 ohms. And then what do I have here? I have here my 6 ampere source. And what I want to compute for now is this, no? Let me call this IXB. Any suggestions to compute for IXB? Try somebody else, no? Let me call Nathaniel. Are you there? What can I use? No? What technique can I use to compute for IXB?
Can we use
Ano?
wait lang po.
Sige, anybody else? Anybody else? Ano technique pwede kong gamitin to compute for IXB? Sige, Ruben. Yes?
Sir, is it current division?
That's right. No, you can use current division because these two are in series, right? These two are in series, and then this branch is just in parallel with this branch, no? So if you take a look at this current just divides itself into this branch and into this branch. No? So can you continue? No? What is your expression now for IXB?
Sir, IXB would be equal to, so 6 amps, the current source, multiplied by 18 ohms over 9.
Over, oops,
Wait,
Careful.
3 plus 6. Oh
over
no,
what?
3 plus 6 plus 6 plus 12. Yeah. So
Over
12 plus 12, 24, 27.
over 27. Okay,
Yeah. Whoops.
which will give you 4 amperes. No, that will give you 4 amperes. So finally, no, my IX is just IXA plus IXB, which is now going to be 7 amperes plus 11 plus 4 amperes, which is 11 amperes. No? Okay, the key takeaway is this, ano? With my switch in position A, I already know the contribution to IX of these two. No? So when I move my switch to position B, then I can just suppress these two and just get the contribution of the 6 ampere to IX and then add it to what I computed for previously. In other words, that simplifies the solution of letter B if you already know the solution to letter A. Are there any questions with regard to this problem? Okay, let's make it a little bit more interesting now. Use superposition to solve for V sub O. Okay, so this is what I want to solve for, V sub O. Okay. I have 4 sources in the circuit, 2 dependent sources, 2 independent sources. How many components will there be to V sub O? Can I ask you, how many components will there be to V sub O? Anyone? Yes, sige, Romeo, how many?
Sir, is it 2?
Why 2?
Kasi hindi po pwedeng tanggalin yung mga dependent.
That's right, no? That's exactly correct, no? We only have 2 components, no? 2 contributors to V sub O, and those are just your independent sources. So again, going back to what we said about superposition, no? In a circuit containing an independent sources, kailangan independent sources, no? Then the current or voltage in any part of the circuit can be seen as having contributions from each of these independent sources. But you should not consider the dependent sources. In other words, you should not say this dependent source acting alone, because a dependent source cannot act alone. A dependent source requires an independent source, no, to have an output. Okay, so there will be 2. Okay, so okay, let's try to solve this problem, and this is probably going to challenge you a little bit. No, it's going to test you in your nodal analysis skills. Okay, so first let's consider the 10-volt source acting alone. So anong gagawin ko dito sa 5 ampere source? I will replace it with an open circuit. No? So ang matitira na lang itong 10-volt source. So let me draw now my equivalent circuit. I have my 10-volt source. Okay. This is 5 ohms. Okay, this is going to be I delta. Okay. I need that because this dependent voltage source relies on the value of that I delta. No? Okay. Now, let me call this V's of O A, no? The value of V's of O with the 10-volt source acting alone. And then I have now my current source. So this is 0.4 V delta. Okay, what is this? This is 2 I delta. And my V delta is here. This is my V delta. And then what happens to my current source? That is an open circuit. How many essential nodes do I have? How many essential nodes? Okay,
Two, sir.
yes, 2. That's right, ano? 2. So I got the answer 2 also from a lot of people in the chat, no? Okay. Remember, an essential node has to be a point of interconnection between 3 or more elements. So this one and this one are no longer essential nodes kasi wala na nakakabit dito, no? So in effect, my essential nodes are now this one and this one. Therefore, how many KCL equations will I have? I'll only have one KCL equation. No? So yung isang essential node gagawin kong reference. So gawin natin itong reference. Let's make this my reference. Okay. And let's call this X. No? In effect, meron akong Vx dyan. And let me do a KCL at X. KCL at X. Okay. So can somebody help me out? What is the current flowing at the 5 ohms from right to left? Anong value nun?
V's of X minus 10 volts over 5, sir.
Okay, so V's of X minus 10 over 5.
5.
Okay, what about, sige, tuloy mo lang, no? What about the current flowing down here?
V's of X over 20.
Yeah, this is 20. No? V's of X over 20, no? And then what about the current here?
V's, I current, sir.
Yeah,
So, sir, V's of X minus 2 I delta
V's of X,
minus 2 I delta
okay,
over 10 ohms. Then, paano, sir, yung may current source, so
well, sinabi mo na, no? So may current source dito. So ano yung current na nagfo-flow from left?
0.4 V's of delta
Okay, so may 0.4 V's of delta. Ano ito?
minus
Minus.
minus.
Equal to 0. Okay?
Oh, okay.
Parang pinahirapan mo yung sarili mo, no? But very good, no? So this is your KCL at X. How many unknowns do I have? 2. Right? I have 2 unknowns. So what other equation must I form, no? Or what other equation can I form so that I can solve for my two unknowns? Can somebody give me that equation? I'll give you a hint. How do you compute for V's of delta? Yes, so Alberto.
X minus 2I delta over 10 ohms.
Okay. You're saying X, the voltage here,
Yes,
minus the voltage here over 10 ohms is what?
would be the would be what dictates the dependent current source, sir.
Okay. First of all, think about it, ano? This voltage, V of X, minus this voltage, is that the voltage across the 10 ohm resistor? It's not, no, it's not. Okay, because you have a voltage across this current source. Okay, so you have to be careful. You have to be careful. There's a simpler relationship between. There's a simple relationship that you can establish with respect to V delta that will provide you a second equation. What is the voltage V sub delta? Okay, what is the current across the 10? What is the current flowing through the 10 ohm?
V sub delta is equal to Vx minus 2I delta, sir.
No. That's the same. I think that's the same answer that was previously given. No?
Sir, is it 0.4 V delta times 10?
That's right. No, but with may isa pang tweak. You're very close.
0.4
Be careful.
0.
Okay.
Sir, negative? Is
Yeah,
it negative?
exactly. Yeah, nakuha mo na negative, ano? The current flowing through this 10 ohm resistor is actually this current, right? There's only one current flowing through this branch, no? There's only one current flowing through this branch, and that's this. It's 0.4 V delta, right? So if I know the current flowing through the 10 ohm, I should be able to get the voltage across the 10 ohm. But the voltage across the 10 ohm is this V sub delta. So what is V sub delta? V sub delta is equal to first negative, negative, because this current will be flowing here from down to up, but the polarity V delta is plus minus, no? Up to down plus minus. And therefore it's against the passive sign convention, and therefore you have to put a negative sign. Negative 0.4 V delta multiplied by 10. It took a while, but finally you got it. Any question with respect to this equation? Do you understand why? In essence, meron akong 10 ohms. Meron akong current dito na 0.4 V delta. Right? So magkakaroon ako ng voltage plus minus 0.4 V delta times 10, which is equal to negative of this V delta. Okay? Okay. From this equation, anong value ng V delta? Anyone? Take a look at this equation. Ano magiging value ng V delta? Yes, Alberto.
Oh, wait, from that equation, sir?
Yeah, from this equation, you can solve for V delta. What will it be?
-4? Or no, positive? 4 V
Yes.
delta, sir. Negative 4 V delta.
Somebody else? What is the value of V delta from this equation?
Sir, is that 0?
It's 0, right? How can this equation be true unless V delta is 0? How can V delta equal to, in effect, minus 4 V delta? The only way that will be true is if V delta is equal to 0. So from this equation, we see that V delta is equal to 0. So this is now equal to 0. So I can now solve for V of x. So V of x, which is equal to V of O of A, is equal to, okay, I won't go through the solution anymore, but you're going to get 8 volts. Any questions? Any questions? So that is with the 10-volt source acting alone. No? That took longer than I had wanted to. Let's now consider the 5 ampere source acting alone. I'll just do this on my own. I hope you can follow. So consider the 5 ampere source acting alone. So what will happen to my 10-volt source? That's going to be a short circuit now. Then I have my 5 ohms. This is my I delta. Okay. This is my 20 ohms. I'll now call this V's of OB. No? V's of OA is with the 10-volt source acting alone. V's of OB is now with the 5 ampere source acting alone. Okay, this is 0.4 V delta. Okay. Okay, this is minus plus 2 I delta. So this is now 10 ohms. And now this is my V of delta. And this is my 5 ampere source. I have to be consistent, no? I have to put my reference there because that was my reference in the first part of my computation. So I should be consistent. Okay, very quickly. How many, okay, other than the ground, how many essential nodes are there? Other than the ground, very quickly.
3, sir.
3, that's right, no? Meaning to say I have to solve for 3 KCL equations. So let me call this X. Let me call this Y, and then this is going to be my third, which is Z. No? So I do a KCL at X. Okay, what is that going to be? That's Vx over 5. If I go too fast, just tell me to slow down. Plus Vx over 20. Minus, okay, what's my third term? It's going to be 0.4 V delta is equal to 0. Okay. That's KCL at X. I do a KCL at Y. Okay. So I start with the 0.4 V delta. That's the current flowing from right to left at Y. And then I have Vy over Vy minus Vz, no? Vz over 10. That's something I want you to be careful about, no? The voltage across these 10 ohms is Vy minus Vz, no? A lot of people will forget that the reference is here, and then they're going to put Vy over 10. In fact, I had started to do that earlier. It should be Vy minus Vz over 10. Okay, what's a last term? Minus 5 amperes is equal to 0. Okay, that's KCL at Y. Do I have to do KCL at Z? Yes or no? Send me an X if it's no. Send me a check if it's yes. Okay, I got one answer, no. I got some answers that are yes, some answers that are no. Sino yung unang nagsagot na no? I think it's Mark. Why no? Si Mark Vanessa. Why no?
Sir, alam na po yung voltage sa Z.
That's right, ano? We can determine the voltage at Z by inspection. Right? Sige, Mark, what is that voltage?
Ano sir, negative 2I delta?
Is it negative?
Ay,
It's
positive.
positive, ano?
Sorry.
Z is positive with respect to ground, ano? So this is 2I delta. Okay, so those are my equations so far. But how many unknowns do I have? Ilang unknown ko rito? 5, no? If I count, I have Vx, Vy, Vz, V delta, at saka I delta. So kailangan ko pa ng dalawang equation. But those equations are very easy to come up with. No? For example, what is V delta? What is V delta? V delta is just Vy minus V sub z. And what is I delta? I delta is just minus Vx over 5. So I have 5 equations in 5 unknowns. Actually, if I substitute this, no, or if I substitute all of this rather, no, into these equations, you really end up with just 2 equations in 2 unknowns. Okay. So it doesn't become that much of a problem to solve this. And if I solve for this, no, so I'm not going to go through the solution anymore. But if I solve for this, I'm going to get v of x, which is VOB, is going to be equal to ano nga ba siya? 16 volts. No? 16 volts. No? So finally, VO will be VOA plus VOB. So this is going to be 8 plus 16, which is 24 volts. Any questions? So the takeaway from maybe this example is we're applying the principle of superposition, but we still have to hone our skills in nodal analysis. So kailangan talagang hasaan ninyo yung mga sarili ninyo sa nodal analysis. Okay? Don't think that nodal analysis is trivial, ano? As in this example, you can see that it can get a little bit confusing if you're not very clear in your minds what the procedure should be. Any questions? Okay, if there are no questions, I'll move on to the next topic. No? Equivalent circuits when a circuit has sources. Okay. So, not last week, 2 modules ago, when we started discussing circuit analysis techniques, okay, nakita natin na kung meron tayong resistive circuit, okay, if we have a resistive circuit, and we're only interested in the behavior of this circuit with respect to, let's say, a set of terminals XY, we're only interested in the behavior of the circuit with respect to a set of terminals XY, then it's possible for us to reduce this into a single resistance or an equivalent resistance. Okay, so natutunan na natin yung mga series combination, parallel combination, and then yung Y to delta and delta to Y, That's to reduce this into an equivalent circuit, which will simplify now the analysis of the circuit, the entire circuit, when finally this is connected to where we want to connect it to. Now the question is this, what if I have a circuit here with sources and resistances? What if we have a circuit here with sources and resistances? Okay. Is it possible to represent this with a simple equivalent circuit with respect to X and Y, no? So I'm saying my answer to that is yes, no? This can be simplified. That can be simplified. So that if we're only interested in the behavior of the circuit with respect to X and Y, we can replace this entire circuit with a simpler equivalent circuit and make it easy now to solve our problem, our circuit problem. So that's what we're going to study next, no? In fact, that's what we're going to study today. We'll continue on Thursday and even next week, no? We're just going to study this. So the first technique that we're going to study is source transformation, no? And then on Thursday, I'm going to introduce Thevenin's theorem, no? We're going to get an equivalent circuit, which we call the Thevenin equivalent. And then correspondingly, there's an equivalent circuit, which we're going to call Norton equivalent. And we're probably going to spend a bit of time on Thevenin and Norton equivalent because there are certain complications that are involved in getting the Thevenin and Norton equivalent that you should be very familiar with. So yun ang gagawin natin for the next 3 meetings, no? But I'll introduce it now. Okay, so the first technique that we're going to study is what we call source transformation. Okay, and what is the principle of source transformation? If I have an ideal voltage source with a resistor connected in series, so this is an example, no? This is an ideal voltage source. I have a resistor connected in series. That can be transformed into an ideal current source with the same resistor connected in parallel. So I can transform this into this, okay, so that if these are the same circuit, no, if this circuit here is the same as this circuit here, that circuit cannot tell the difference whether it is the voltage source in series with RS or the current source in parallel with RS. Meaning to say, this and this are equivalent. And you call that source transformation. If I'm converting from this to this, it's very easy, no? Itong RS na to, yun din yung RS dito. Tapos itong I na to is just V's of S over R's of S. If I'm converting this to this, okay, again, the same RS, and then this time V's of S is going to be equal to IS multiplied by R's of S. Now, it's very easy to see, no? That's very easy to derive. Let's consider the circuit on the left, no? Let me compute for V. If I compute for V on the circuit on the left, I'm going to get V is equal to V's of S minus I times R's of S. This voltage is this voltage minus the voltage drop across this resistor. The voltage drop across this resistor is the current I multiplied by the resistance. Okay, dito naman sa kanan, let me compute for I. Okay, let me compute for I. So to compute for I can do KCL here. No? And what am I going to get? I'm going to get I is equal to I's of S minus V over R's of S. No? I is equal to I's of S minus V over R's of S because I will have a current flowing down here. That current flowing down here is this voltage, the voltage across the resistor, divided by the resistance value. So this current plus this current is going to be equal to this current, and therefore this current is this minus this. So ito yun. So if the left is going to be equivalent to the right, kung pareho yung kaliwa at saka kanan, no? Then V and I on the left side should be identical to V and I on the right side. In other words, itong I na to, pwede kong i-substitute dito. I can substitute the value of this I into this expression. So what am I going to get? Now I'm going to get V is equal to V of S minus I of S minus V over R of S multiplied by R of S. If I simplify this, oops, sorry, this is V. That's V. If I simplify that, what am I going to get? I'm going to get V is V of S minus ISRS plus V. No? This cancels. So V of S is equal to ISRS, no? Which is this equation. And if you solve for IS, that's just V of S over RS. Are there any questions? So very simple derivation. So let's put this to practice. So here's an example. Solve for the power associated with the 6-volt source. No, I solve for the power associated with the 6-volt source and indicate whether the source is absorbing or delivering power. So if I'm only interested in the power associated with the 6-volt source, what I can do is I can convert this, no, to an equivalent circuit. So convert to a simpler equivalent circuit. If I'm interested in the power associated with the 6-volt source, I just have to make sure I preserve the terminals of the 6-volt source. So ang i-convert ko is everything else outside of that 6-volt source. I try to convert this into an equivalent circuit. So when you do that, usually you start at the far end, no? Umpisa ka sa pinakakanan, and then you work your way back toward the 6-volt source. Okay, do you see what my first step should be? Is there a source conversion that I can do? Anyone?
Sir,
Yes, go ahead.
just a guess po. If we're trying to get, okay, well, this just came up in mind, just a guess po. We can use the 6-volt source and the 4 ohm resistor and then convert it into maybe like a current source. I'm not so sure though.
Yeah, you're going the right direction, but you're going against what I said earlier, no? If
Oh.
I convert the 6-volt source and the 4 ohm source into a current source, then I'm going to be then the terminals of the 6-volt source are going to disappear, no?
Okay.
And if the terminals disappear, then I won't have any way of determining now what the power associated with the 6-volt source is. Because in essence, I made my 6-volt source disappear.
Right.
So that's why I said, if you want to get the power associated with this, you work your way to the right and then go toward the left. No? So, okay. Having said that, do you see what I can do? Anyone? Ano yung pwede kong
Use source transformation, sir, dun sa 40-volt source and 5 ohm resistor.
Exactly, This is where I can use source transformation. So I can convert the 40-volt and the 5 ohm into a current source. What would be the value of the current?
8 amperes, sir.
8 amperes. And what would be the resistance across it? It will be the 5 ohms. Right? So if I do that, yung una kong conversion, I'll have the 6-volt source. Okay, this is going to be a lot of drawings, no? Hindi ko na ilalagay yung mga ibang values, ano? Okay. I'm going to have my 20 ohms here. And then, okay, my conversion, I would have a 5 ohms here. And then I would have an 8 amperes here. Do you see that? If you see that, no, just give me a thumbs up, no? Okay. So that is my first conversion. Now, can you see now something I can simplify?
Sir,
Yes,
the 5 ohm and the 20 ohm are in parallel. So
That's right.
we can simplify it into one.
I can simplify the 5 ohm and 20 ohm into a single resistance, which is going to be equal to 4 ohms. No, product over sum, 100 over 25. This is going to be 4 ohms. Okay. Now, if that is 4 ohms, I can now what? Put that in series with the 6 ohms over here and the 10 ohms over here. Okay. So what is going to be my next iteration? No? My next iteration, I'm going to have my 6 volts. Okay. And then I'm just going to have now a single resistance here. So what is this? This is 4 ohms. This is 30 ohms. What is the value of this single resistance going to be?
20 ohm.
Ano, no? Sorry, I didn't hear. Pwede pakiulit. Sige, let's do it step by step, ha? Kasi baka nalilito kayo, no? So I will keep the 4 ohms, 30 ohms. Okay, there's a 6 ohms here, no? There's a 10 ohms here. And then this one, no? This one, I will convert now to a voltage source, no? The voltage source would have a series resistance of 4 ohms. And what is going to be the value of the voltage source? It's going to
24, sir.
be times 4. Is that what you're going to answer? It's going to be 32 volts. Does everybody see that? Does everybody see that? Yeah. I saw a question, how is it possible to convert the 40 volt to an 8 ampere without knowing the full KCL of the node between the 6 ohms, 20 ohms, and 5 ohm resistor? Now, maybe you missed it, this 40 in series with the 5, no? So essentially, this 40 in series with the 5 ohms, okay, this 40 in series with the 5 ohms, sorry about that. With respect to, let's say, this is terminals X and Y, is equivalent to this 5 in parallel with 8 ampere, no? With respect to X and Y. So wherever this existed before, okay, I can connect this instead without changing the behavior of the circuit. So that's what I did here. That's what I did here. Where this was connected before, I now replaced it with this. And that won't change the behavior of the circuit. Did you understand that? I think it's Siri that asked the question. Okay. Okay. Thank you for the question. No? I hope that also clears it up with other people. No? So let's go back. No? So we already converted this to an 8 amperes in parallel with 5 ohms. Now we saw that these two are in parallel, so we can convert that now to a 4 ohm resistor. No? And then the 4 ohms in parallel with an 8 amperes can now be a 4 ohms in series with a 32 volt. Okay. I think everybody saw that. And so now I have this, and this all in series. No, I have 6 ohms, 4 ohms, and 10 ohms that are all in series. So what's my next iteration going to be? No, I'm going to have my 6 volts. Okay. I'm going to have my 4 ohms. Here I'll have my 30 ohms. What will be this resistance? What will this resistance be? It's just going to be 6 plus 4 plus 10 or 20 ohms. No? And then here I have a 32 volt source. Any questions? Okay. So what next? Any suggestions? Yes, Romeo.
Sir, convert it po again to current source.
Okay, so again, no, makulit, ano? Pero we can convert this again to a current source, no? So anong magiging value ng current source?
$1.6 amps.
Yeah, the current source is going to be 1.6 amps, no? And then it's going to be parallel to the 20 ohm. No? So again, kung gawin natin step by step so that it doesn't confuse you. So 6 volts, 4 ohms, 30 ohms, meron akong 20 ohms, tapos dito, meron akong 1.6 amps. No? So siguro obvious na yung next step, ano? So next step is I can combine these two. And this is going to be 12 ohms. Okay, that's going to be 12 ohms. So eventually, finally, what will I have? I'll have my 6 volts. I have my 4 ohms. Itong 12 ohms, i-convert ko to uli. I will convert this again to a voltage source. So my 12 ohms is going to be in series. My 12 ohms will be in series. What will be the value of the voltage source? The value of the voltage source will be 1.6 amps multiplied by 12 ohms, or that's going to be 19.2 volts. 19.2 volts. Actually, at this point, we can already solve the problem. I can already solve for this current I. I is just 19.2 minus 6 divided by 16. This is going to give me 0.825 amperes. I already have the answer in my notes. Okay. So P, the power of the 6 volt source will be 6 volts multiplied by I, and this is going to give me 4.9 95 watts. So this is my answer. .95 watts. Note that the direction of current follows the passive sign convention for this particular element, and therefore my power should be positive. If the power is positive, what does that mean? Is this delivering or absorbing?
Absorbing.
Absorbing.
Absorbing, no? Actually, obvious naman, ano? It's a source, no? But the current flowing through it is from plus to minus. You need to say it's absorbing, no? Because if it were delivering, then the current should be flowing out of the positive terminal, no? Not flowing into the positive terminal. So can you see now the usefulness of source conversion? So if we go back to some of the problems we had earlier, no? For example, kung balikan natin ito, no? We could actually have converted this to a, well, depending, no? Kasi if I convert this to a current source, mawawala yung I1, ano? But if I wanted to get, for example, some other quantities here, I could have converted this to a current source, ano? And there are many other opportunities for voltage source, current source conversion. Okay. Okay. Special cases, and I discussed this the last time we met, ano, in the example that I gave. If I have a resistor in parallel with an ideal voltage source, this resistance is not going to affect the voltages or currents connected to terminals A and B, no, or to the voltages and currents connected to this at the circuit connected to terminals A and B. No? And if I have a resistor in series with a current source, with an ideal current source, this resistance is not going to affect the voltages and currents to the circuit connected to terminals A and B. So if I were interested in voltages and currents connected to the circuits at A, B, I can remove this, or I can remove this. Okay, just a word of warning. No, itong R's of P and these R's of S will affect the power being delivered by the source. So if the question is, what is the power being delivered by V's of S, wag niyo tatanggalin tong RP. No? Same thing here. What is the power being delivered by IS, wag niyo tatanggalin ito. No? Pero kung yung question is something connected to this, then you can take this out or you can take that out. So that was in my example last time. I have a final example, but I'll leave it to you already to compute this. Ano? So solve for V sub O by simplifying the circuit. Again, the technique that you're going to use here is source conversion, source interconversion. We're solving for V sub O. Okay, and therefore, when you see something like this, 125 in parallel with 250, then you know that to solve for V sub O, this will have no effect. No? And then you have this 8 amperes in parallel with 10 to solve for V sub O. This 10 will have no effect. So you can simplify the solution to your circuit. Yes, there's a question.
Sir, in problem sets and exams, is it okay to do two source conversions at the same time?
In problem sets and exams, kung nakuha na natin yung technique, you should be able to use it, di ba? kung hindi pa natin nakukuha sa klase, then I would recommend you don't use it first. Ano? Maybe you use it to test, to check your answer, but I would recommend not to use it first so that the the principles that were taught in that particular module can be ingrained into you. But actually, I don't know how the checker will approach your solution, basically. No? Did I provide you a satisfactory answer?
Yes, sir.
Subukan, I mean, kung, for example, no, you're solving a problem sa module, I guess sa module 3, right? And you're not supposed to use this yet. My recommendation is, wag niyo munang gamitin, no, so that yung mga natutunan niyo sa module 3 can be better ingrained into you. And then maybe you can use this technique to check your answer. At the same time, practice na rin for module 4. Any other questions?
So the PowerPoints will be sent after this class, right?
Yeah, these annotated slides I'll send to you.
Sige po. Thank you po.
Okay, so that's all I have. No, so like I said, next meeting we'll take up Thevenin, then Norton, and then as a result of Thevenin and Norton, we can discuss a phenomenon which we call maximum power transfer. Okay, that's it. Yeah, that's it for the afternoon. No, I'll stop the recording now, and then I'll close the session as soon as